Good evening, class. We're going to continue our lecture on neuroanatomy. So we're just going to review the divisions of the nervous system real quick. So we have our central nervous system, which is composed of the brain, which consists of the cerebrum, the cerebellum, subcortical structures, and the brainstem. And we also have our spinal cord, which makes up our central nervous system. In addition to this, we also have the peripheral nervous system, which is composed of the cranial nerves, spinal nerves, and sensory receptors. So you guys, right now we're going to really just focus on the brain. This is going to be the next part of our lecture. So the brain is comprised of the cerebrum, cerebellum, subcortical structures, cerebellum, and brainstem. Let's draw our focus to the cerebrum, which is divided into 4 lobes. We have the frontal, temporal, parietal, and occipital. So if we zoom in on this image, we can see our frontal lobe is obviously in the front of our brain. Our parietal lobe is kind of midway in the back, somewhere in the middle. Our temporal lobes, there's one on each side. And we have the occipital lobe in the back. So, lobes on lobes on lobes. So our frontal lobe is our decision maker. It's involved in planning, inhibition of voluntary movements, thought processing, etc. So we can think of our frontal lobe as our control center. Some major structures that we're going to focus on that are within our frontal lobe are the Broca's area, the precentral gyrus, or also known as the mothership. And we're not going to really cover too much on the premotor region and the anterior portion of the frontal lobe, but there is information in your notes if you want to focus a little bit more on that. But for our quiz tomorrow, it's not going to pertain to that. So the Broca's area is located within the left hemisphere. It deals with speech planning. And then our other major area within the frontal lobe is the precentral gyrus. We can kind of think about this as it's referred to the motor strip. It starts voluntary movement. We can kind of think about this as like sometimes in the movies you see that people have to hotwire cars. We can think about this as like our go system. So maybe we're hotwiring our car, we're getting everything started. This is going to start all the movements that's going to make our car go. So that's what we can think about when we think of our precentral gyrus. Moving on, we have our parietal lobe, which deals heavily with processing information, interpreting visual information, processing language, etc. Our major structures that we're focusing on within the parietal lobe are the postcentral gyrus, also known as the primary sensory strip. And this just receives all our sensory information. So everything is going through the postcentral gyrus for all of our sensory info. So if we're touching something, if we are feeling stimulated, it's going through this structure. We also have our angular gyrus, which is involved in mathematical calculation. It aids in cognitive function, which can go from thinking to understanding to trying to comprehend. And it's also involved in reading and writing. So if there is an impairment within this structure, this can cause dyslexia, which is a reading disorder. And it can also lead to dysgraphia, which is a writing disorder. So we have our temporal lobe, which focuses on hearing and understanding speech. So our 2 structures within this are Helsch's gyrus, which receives auditory information from the ears. So this is pulling all our sound in. So when you're outside and you're just waking up and you're hearing the bird chirp, this is your Helsch's gyrus facilitating that. We also have Wernicke's area, which is processing receptive language. This is also located within the left hemisphere of the temporal lobe. This is how we're processing receptive language, which receptive language is understanding and comprehending language. So this is how we're actually trying to understand and formulate language. That sometimes if there's aphasia or if that could be related to a traumatic brain injury, related to surgery, that if there's damage to the Wernicke's area, we can understand language, we can hear what someone's saying to us, but we have no capability to actually formulate that speech. And last but definitely not least, we have our occipital lobe, which is our visual processing center. The major structure within this is the calcarine sulcus, which is the main focus area for receiving visual information and just allowing us to see and so forth. So you guys, tomorrow we're going to continue our lecture and dive more into the lobes, and then we'll be moving on to the cerebellum. Thank you.